In this video, we will write concurrent server with Haskell. We will use a network package for this. It provides a low-level networking interface. Okay, let's start with stack. We will use stack to build our new project. I will call it simple server, and I'm going to use a snapshot nightly 2021-11-27. If you didn't know how to use stack and what is a stack, please see my previous video about stack. Okay, let's run this command, and this command will create the new project for us. You can see here in my Haskell directory I have this new folder. Okay, now I go to my IDE and open the folder of this project. Okay, first of all I need to go to app folder, and you can see here the main module of the project. First of all, I don't want one exe file, the main file in this case. I want two files. I want the server file and the client file. So I rename this file to a server, and the next thing I will copy it and create a new file client. Okay, let's look at our client file. Okay, I need to change here to client module, and this is okay, and this is okay. Now I need to edit my package.yaml file. You can see here executables. I will use first of all server. First executable is server, and the next executable will be client. Okay, and the module of the client is client HS. Now let's try to rebuild our project. So first of all I need to set up it. Stack setup, and then stack build. Okay, and you can see these errors here. This happened because stack didn't know the location of my modules. So I need to use some option here. In my executables I need to add here option main is give a location to my server file, and also in client same option, main is client. Now let's try to run, and you can see that it is okay. Now I think I can run all the files. So if I run stack run server, okay, I can see my mock stream. Okay, it's work. Now let's go to package.yaml file and add our packages. So we need some dependencies here, and the first dependency is network package. The second dependency is byte string, and the last dependency is binary. So we will need them later. Now let's go to our server file, and we need some function here. This is a simple function. This is a function of factorial. So I need to my to implement some job for my server, and I want to use factorial for this. Okay, this is a simple implementation here for factorial, and let's try to rebuild. Stack build. Okay, because we write in a concurrent server, we need to define one function which will be run in its own thread, in a light thread, and it accepts only one argument. This is a socket in which we want to communicate with the other side. Okay, let's call this function talk and accept a socket. And this function needs to produce an action. So this is the IO action. First of all, we need to call our receive function to extract some data from the socket. Here we provide our socket and the number of bytes which we want to, maximum number of bytes which we want to read. And we extract this as a message. So let's print this message. And next thing we need to do, we need to repeatedly receive this message until we will receive a null string. Okay? Sorry, not so. We need to repeatedly receive this message again and again and send the response until we get a null string. So we can represent this thing with unless function, which takes some boolean value. In our case, we check our message for a null, and if this is not null, we do the send all to our socket message. So we send our data to a message, so like an echo. But later we will change this to our factorial function. And we need to call our talk function again. So like a loop in imperative language. So here this is a recursion. So now we have this small piece of code which define our coroutine, or like thread or just thread in Haskell. So it just have socket and repeatedly talk with some external socket. Let's write type signature for our function. This function take a socket and produce IO action with no result. Next thing, we need to create run TCP server function which will initialize our server and run our server. So it will take maybe host name, so maybe host name, and then it will get service name. This is a just type synonym of the string. Here we will receive a port on which we want to run our server, and also it will receive our handler function, this function, and we can take this type signature from here and paste it to here. And because this is this function run TCP server will produce some side effects. This is an IO action function. And no result here. Okay, now in background I will implement this run TCP server function, and after that we will line by line analyze how this function works. So this is the implementation, and let's look at it. So first of all we resolve the address. We will use the helper function resolve here. For this we will just create some data structure with the default parameters, and here we provide some parameters for our new socket. Okay, and so this function getOtherInfo resolve the best address to which we can bind our socket, and we pick up, it returns the IO of list of addresses, and we pick out the best one with head function. And here we extract this address from the resolve function IO with type IO, and next we use this address to open our socket and initialize it and start to listen connections and accept them. Here we use a bracket function which takes three actions: the start action, the end action. So at start we open our address with this function, and with here we create a socket, initialize it, and return here. So here this action contains the socket, this parameter. This parameter is just close socket at the end of all this action. Then the loop is ending, this action will be performed. So, and the last action which occurs in the middle of this action. So we open, then we loop, and then we close. And this action defined here, we take our socket, and forever we start to accept the sockets, and so here we use a bracket on error function which start to do this action. So it accept some socket and do this forever. So we accept a socket and fork our main coroutine which talking to our clients. So here we run our TCP server, and this parameter talk, which we implemented at the start of the video, we push it here. Here it use as a server parameter, and we use it here. So we fork our light thread, this light thread, with a socket, which we accept. And finally, of course, if our light thread fails, we must to gracefully close our connection. Okay, I write enough code here. Let's try to build this stack build. Of course, there is an errors. Okay, I do error here, send all, this send all, not this. Let's rebuild. Okay, and it's built. So we have an echo server now, I think. Let's try to run this from stack run server. Yes, and I think it's run. It's run on the port 3000. And now let's look at our client file. I will implement this and we will analyze this file. So this is the client implementation. You can see that here the main coroutine, which the main light thread, which talk to server, he is implemented here. We take some socket and send to the socket some data. This is just a string, 5000 here. When they print that, we wait for response, then we receive the message from the socket here, and here we put they receive this message. So we read a message from the server and put it to the screen. Okay. And this is the implementation of our TCP client, which do the resolve an address as in a server, and then it use this client function, which received here our main function, to do some job. So it first of all, it's open address and connect to the socket of our server, and this address, this socket goes to client function. Our client function do our sending data, and finally we close the socket. So I think this should work. Let's try to compile. Stack build. Okay, main client main. Okay, paste extra untitled model here. Let's do so. Try to rebuild. And it run. Okay. Now I will run server here, and then here I will call the client. I will go to my Haskell directory. So Haskell, our project called simple server. Stack run client. Okay, we can see that client sent 5000 and as an echo it received 5000. But I don't want just echo, I want to my server do some processor bound job. This is our factorial function, and I need to take this request here and produce a factorial for received number in the message. Okay, I will implement this in background and we will analyze this. So here I do some modifications. I calculate the factorial. So I receive this message here, do some unpacking of this message, and converting it to integer and produce the factorial of this integer, and the result here is an x variable. Okay, not variable. In Haskell there is no variables, only names. So we evaluate this value, and the name of this value is x. Okay, and next thing we just send. We do some job and send message to our client. But let's do not say send our message. Let's send our result. Okay, we will need to convert it to string and pack it to byte string. And now I think our client will receive our result. Okay. Okay, let's run the client. Oh, very big number, 5,000. I think let's do something small. For example, 5. Okay, let's run for 5. We can see that the server received 5, it calculates 120, this is the factorial of 5, and here in client we also received 120. Okay, the next thing I want to do is to compare this simple client-server implementation with implementation in Python language and show why the Haskell is so awesome language. It's really nice. It have some advantages over Python, and we will see this in the next video. And for today, I think this is all. Thanks for watching. Push subscribe button, push like button, write comments, and see you in the next video. Bye.